Alright class, welcome to the topic 5 review, which means you do have a test next class. Let's get started. Fill in the blank. A triangle that is equilateral is also called, there's two answers to this. If you got an equilateral triangle, that means all the sides are the same. One thing we learned that if all the sides are the same, then all the angles are the same. So one answer you could put here is equilateral is also equiangular. I forgot how to spell equiangular, but equiangular is the correct answer there. Also, in the case of a triangle, if a shape is equilateral and equiangular, you could also call that a regular triangle. That's another name for that. The blank of any triangle has sum to 180. That's the interior angles. Interior angles of any triangle. If I add up, in this case, 60, 60, and 60, that will add up to 180 degrees. The sum of the two adjacent interior angles is equivalent to the exterior angle. For example, up in this triangle, if I add these two together, it will add up to the exterior angle. Alright. The blank of an isosceles triangles are congruent. There's two answers here. You could put the legs. That's one answer. In an isosceles triangle, the legs will be the same. You could also put base angles. The base angles will also be the same. Remember, this is the vertex. You got two base angles, legs and base. Base, legs, base angles, vertex. The blank is always along the side of a right triangle. If you got a right triangle, in a right triangle you got two legs and a hypotenuse. The hypotenuse is always going to be the longest side. A triangle with different measures for each side, if they're all different measures, it's called scalene. If they got two measures the same, it's called isosceles. The blank is formed by the congruent legs of an isosceles triangle. So this leg and this leg make the vertex angle. So that's vertex. A blank is an angle that makes a linear pair with an interior angle of a triangle. So if I were to take this and extend it out, this and this are now a linear pair. That's called the exterior angle. You got an interior angle and an exterior angle. Exterior angle. Okay, next, some sometimes, always, or never. These get tricky. Two of the angles of a right triangle are, if we've got a right triangle, supplementary means adds up to 180. Two angles will never add up to 180 in a triangle. It's all three angles have to add up to 180. However, in a right triangle, these two angles would be adding up to 90 always, because you got 90 plus another 90. So if this was complementary, it would be always true, but supplementary, never true. The vertex angle of an isosceles triangle is sometimes acute. We can make an isosceles triangle like this, where we do have an acute angle. We could also make an isosceles triangle like this, where we have an obtuse angle. You could also make a right isosceles, so it's sometimes acute. If one angle of an isosceles triangle is 60, then the triangle is always equilateral here. If I make one angle 60, and I know that there's some sides the same, like an isosceles, then that makes all the angles 60. A scalene triangle is sometimes. You can have a scalene triangle that has an obtuse angle. An isosceles triangle has two congruent angles. it always has at least 2. It might have 3, but it always has at least 2, so that's kind of a tough question to answer. Use the diagram below to answer the parts of this question. So here we have solve for x in this picture. Big hint here, we've got 2 legs that are the same. So that makes these base angles the same as well. Alright, so now all I need to do is just take all this and add it up. 20x minus 10 plus 20x minus 10 plus 9x plus 4. And that will add up to 180 degrees. Alright. The key was that we have an isosceles triangle and these two are the same. So now we add it all up. We got 3 angles adding up to 180 degrees. So that's 20 plus 20 plus 9 is 49x total. We got negative 10 plus negative 10 plus 4, which would be negative 16. Alright, so now take these 16 over and now divide 196 by 49. You get x equals 4. Alright, classify the triangle by its angles and its sides. So if I plug 4 in, you get 80 minus 10, which is 70. That's acute. That's acute. 36 plus 4 is 40. That's acute. So all the angles are acute. So we'll call this an acute, and it's isosceles. It's acute isosceles. That's what we're going to call that triangle. Number 15. We've got 2 triangles, and it says they're congruent. So I'm going to go ahead and draw that picture. CJW and AGS. I made them corresponding. We got that A is congruent. A is 50. J is 45. And S is 16 plus 5. Alright, now because their triangles are congruent, this is also 45, and now I can just add all these up to 180 degrees. Alright, so I'm adding up all of these angles to 180 degrees. That's 16x plus 100 equals 180. 16x equals 80. 80 divided by 16, I should know that, is 5. Alright, cool. Next, if this is isosceles, so we can go ahead and put some marks in here. If this is an isosceles triangle, we know that that's the same as that. M is the vertex. We know that this angle is the same as this angle. It also says T is the midpoint of LN, so if this segment has a midpoint, it makes this length the same as this length, because T is the midpoint. Which of these can you use to prove that these 2 triangles are congruent? So at the moment, we can use side, angle, side. So you can definitely use side, angle, side. However, this length is shared, so that opens up side, side, side. Anything else we could use for that? That's all we can state for sure. So you could use side, angle, side, or side, side, side. Next, we're going to prove that triangle PQR is congruent to triangle STU. And we want to prove it by angle, side, angle, so we need that info. We have that R is congruent to U. That's an A. We have that P is congruent to S. That's another A. What we need to do is we need to go and plant some evidence. So we have angle, side, angle. So that would be that and that. So we need PR needs to be congruent to SU. That's what we're looking for. If we make these congruent, then we've got angle side angle. Alright. 18 is a very similar problem. Let's take a look at 18. In this scenario, we've got PQR and we've got STU, and they tell us that Q is congruent to T. They tell us that PQ is congruent to ST. At this moment, we've got an angle and a side, and we need to plant some evidence. So we've got angle, angle, side. So we do not want this angle because that would make angle, side, angle. We want this angle, R and U. Angle R congruent to angle U, and that completes our angle, angle, side, angle, angle, side. On to the back page, number 19. We have an exterior angle, and one of the theorems we learned is that all the angles add up to 180, and the two interior angles here will add up to the exterior, so this just has to be 30. 30 plus 30 is 60. Next, same thing here. We have that 4x plus 11 plus 8x minus 1 is equal to 154. These two angles add up to 154. So that would be 12x plus 10 equals 154. 12x equals 144 when you subtract the 10, and x equals 12. Alright, next. Mark one piece of additional information to make HL possible. Now, there are right triangles. This is the hypotenuse, this is the hypotenuse. That's a leg, and that's a leg, so if we mark those, then we have HL going on. These triangles have to be congruent now because of these marks by the hypotenuse leg. Write a statement that indicates the triangles are congruent. So the first triangle you write really doesn't matter. I'm going to go 1 mark, 2 mark, 3 mark, so that's RQM. But the second triangle has to follow the same 1 mark, 2 mark, 3 mark, so that'd be QRS. Like that. Number 23. State if the two triangles are congruent. Is this enough info to state that this triangle is exactly the same as this triangle? Do you have enough information to make that conclusion? That's a life skill. And in this scenario, what do we have? We've got a set of sides, we've got a set of angles, and that's all we have. Anything else would be speculation. So we're going to say not necessarily congruent. We just don't have enough information. Over here, we've got vertical angles, so we've got a set of angles, we got another set of angles, and we got a set of sides. Now that is enough information by angle, angle, side. Number 25, getting down into some of the puzzle problems, I'd call them. So starting off, we got vertical angles there. We've got a triangle here, so we know triangles add up to 180. So it has to be 30. This has to add up to 180 degrees. This is where people often miss this. We have a nice straight line, which makes 180 degrees there. So in your calculator, start with 180, subtract 30, subtract 65, you get 85 for that. And then these have to add up to 180 degrees. So 25 plus 85 minus 180 be 70. 70 degrees was the answer for that one. 26. Another puzzle. It's tempting to just say that this angle is 33, but they're not. This angle is 33. These are your vertical angles. And now we've got 180 degrees again. So 180 minus 39 minus 33 would be 108. We have a linear pair here. So take 108 and subtract 180, you get 72 here. We have a linear pair here. to get 63. And now we can use 180 degrees here to figure out that this has to be a 45-degree angle. Down here on 27, this is all about the isosceles triangles here. So if this is 118, these two have to be the same. So how I'm going to figure that out is going to my calculator, I'm going to plug in 180. I'm going to take away 118, which gives me 62. Now 62 has to be split evenly. I'm going to divide that by 2, get 31. So these angles here are all 31. And then we got vertical angles, which makes that 31, which makes that 31, which makes this 118. And now we can use a linear pair here. 180 minus 118 is 62. So this was all about isosceles triangles here. These two are the same, these two are the same, these two are the same, which makes that 118, and then we got a linear pair right here, so these two have to add up to 180. Alright, last problem. We can start this one with a linear pair right here. This has to be 60. And because this is isosceles, this is also 60. These two will be the same. And 180 minus 60 is 60. Because this is 90, this has to be 30, because what's 30 plus 60? 90. And now to find this last angle, we've got a linear pair here. So this has to be 150. 150 plus 30 is 180 degrees. How would you find these two angles if I asked for these two? You take your calculator, take 180, and subtract 30, which leaves 150 to be split. By the way, you can see that these two angles add up to that exterior angle. That's 150. And then you got to divide it by 2, so 75. Okay, so that's the end of the review. If you did it all, you can get a bonus on this assignment if you put the word mathlete at the top of your page when you submit it. Put mathlete, and don't forget your name, or else I won't give you credit. So name, put mathlete. By putting mathlete, that tells me that you actually watched the video. Okay, bye.